Okay, let me explain the next task that's necessary in the code. We need to create a function to identify local minimum. So I should say local, instead of saying local minimum, I should say local minima within a vector. If you recall, we have a function that's actually a function of theta. Theta runs from 0 to 2 pi. So you have some function, and you may remember that we had several dips in the function. So we want to identify these places where the function dips. Also, if there's a dip at 0, we need to identify that as well. Alright, so if you remember also that this function is represented as a vector, so the way to identify the locations of the minima is to identify the indices where the minimum takes place. For instance, this would have index j1, this might have index j2, this might have index j3. Right. Okay. This function would be represented as a vector, we call pvec, because it's the value of a polynomial. And we are looking at the places where this function takes local minimum values. And then we will perform cubic interpolation in the neighborhood of these local minimum values. The other thing I do want to emphasize is that 0 and 2 pi are actually the same point. So we'll need to treat this point also separately. In this case, this might be a local minimum because it dips here and also dips here. Alright? So here's an outline of the code. You can call the function local minfun. Let's go here and find where I am. Okay, we'll just do this so we can see the cursor. Okay, so you define a function local minfun. The inputs would be a one-dimensional array, a pvec, which is a vector of polynomial values. Actually, it's going to be the absolute value of the polynomial, but that's not a problem. Okay, the output would be a vector of zeros and ones, and I'll call it invec. Like, suppose I like to put the ind in lowercase just to be consistent, so let me change that to a lowercase. Okay. Right. By the way, this is in the OneNote this is the last page in OneNote, so you can refer to these notes. Okay, now here I wrote this wrong, I changed the name here. So invec of j will be 1 if pvec is a local minimum at index j. So for instance, my invec would be has the same size as pvec. Okay. We want to create invec so that it's 1 for every index where pvec takes a local minimum value. So for instance, in this case, we would have a 1 at entries j1, j2, j3, and also at 0, or maybe at 2 pi, depending on which one is the lowest. Okay, right. So for these values of the index, the value of invec would be 1. For the other values of the index, you'd have value 0. So if I was going to represent the invec, what it would look like, so pvec might look something like this. Let's give some example. If I take pvec, okay, let's just do something. This 1, 2, 4, 3, 5, 4, 2, 3, 6, 4, 3, 2, 1, 2, 3. Okay, so this is my pvec. All right. So let's see where there are local minimum in this vector. Well, local minimum means that the value of the entry is lower than its left neighbor and right neighbor. So you can see, for instance, 3 is a local minimum because it's less than 4 and 5. Here I have 2 is a local minimum because it's less than 4 and 3. Let's see, we have here 1 is a local minimum because it's less than 2 and 2. And we also have this 1 is a local minimum because it's less than 2 and 3. Remember, the vector wraps around. Okay, so these are my local minimum entries of pvec. So in this case, in this particular case, my invec would look like 1 because that's a local minimum, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0. So that's the invec that we would like to generate. All right? Now mathematically, the local minimum of a vector occurs when the value of the vector at that index, pvec of j, is less than or equal to the previous value, and it's also less than or equal to the subsequent value. So pvec wraps around, so you must accommodate pvec 0 and pvec minus 1 specially. Now I would like to say that you can do this using a loop, but you can also vectorize this code. So you might think about how to do this. So you can do this, or you can use vector operations. Now vector operations are actually preferable, but they're more difficult. You might start out by programming a loop and then see if you can change it to a vector form of the code. Alright, so this is the function that I would like you to write, and it's the next necessary function that we need in order to finish our algorithm. Alright, very good. Let me know if you have any questions.